Hi everyone, in this video we will test 4 of the best small LLM models that you can run on your computer, and we will test these models on 7 areas. So let's see. These are 7 areas that I like to test with real test. I know there is the arena where you can check the leaderboard, but the leaderboard usually is for very big models. I like to test by myself on more specific areas, and so instruction following, embedding, so that you can extend also the knowledge of these models, tools, so the ability to use functions that you can prepare for your use case, reasoning and math, knowledge, coding, and big context, which is probably the most useful features of this local artificial intelligence. So let's start with knowledge. So this is a question that is useful to understand how these small models are aware of the world. So write the first capital of Italy. Usually these models answer with Rome, which isn't the first capital of Italy, but it was the capital of Roman Empire. And as you can see, with the first model that we have is this one. It's Gemma2. So the models that I will test are Gemma2, this one, qwen2.5, and it's 5.4 gigabyte. Then we have Lama 3.1 8B, same quantization, 4.6 gigabyte. So you need this memory, RAM memory free if you want to use these models. Then Mistral Nemo 12B, 7 gigabyte, and then qwen2.5 7B, 4.4 gigabyte. So the size it's similar, but the biggest one is Mistral Nemo 12B. First question for knowledge. We have write the first capital of Italy, and here the answer is correct. Sometimes you see the reply in Italian because my system prompt is in Italian, but if you have an English system prompt, you will get the English answers, or you can specify the language in the question. So Gemma2 is correct. Then I ask another ambiguous question, which is translate the sentence from Italian to English. Mi piace andare a pesca e mangiare la pesca matura. And here also we have a correct answer. Sometimes with the small models, they do not understand the meaning of pitch. Here pesca is fishing, and here pesca is pitch, so it depends on the context, but here we have a correct answer. Let's see the second one, which is after Gemma we have Lama, And here we have the first capital of Italy is Rome, which is wrong, but then it changed. So during the Kingdom of Italy, it was Torino, but if we consider the Roman Empire, so it was also Rome in the past. So we have it's a correct answer, but a very long answer. And the same is no. Here the answer is wrong. So the translation of the sentence is wrong, because as you can see, I like to go fishing and eat rip fish, but it wasn't fish, it was peach in this situation. So llama3.1 here is wrong. Let's see another one. And here we have Mistral Nemo, so the biggest one. The first capital of Italy, Torino, right? And translate the sentence, I like to go fishing and eating rip peaches. So this is correct in both. And the last one is qwen. The first capital of Italy is Rome, which is wrong. And then it mentions also Torino in 1861. So the answer isn't very good. And here with the translation we have a similar translation, which is correct. I like going fishing and eating rip peaches. Okay, this was the first test about knowledge. Let's see the second one, which is reasoning and math. And okay, this is the question. If the battery of my electric car loses 5% of its charge per year, how many years will it take for the battery to last only 50%? Simulate the future years. So let's start with Gemma. And here we have a simulation. So the first year it's 100%, then 95, 90. But this answer is wrong. Probably with bigger quantization, also Gemma can answer to this question. So Gemma is wrong. Let's see llama3.1. And here we have an example of reasoning, and this is the simulation with just the result. And it says after 13 years it will have the 50% of capacity, which is correct also, but we have just some calculation. Let's see another one. So Lama and then Mistral Nemo. Here we have a formula, but we don't have the simulation, and here the solution is about 14 years, but we don't have the simulation, so I don't like much this answer, but it's close to the solution. Let's see the last one, qwen2.5 7b. And here we have more reasoning and also the calculation. And here we have all the steps, so it's also useful to see the reasoning about this answer and which is the most precise answer. 13.52 years to reach the 50% of capacity. And I don't know why we have the simulation, but after the 13th year, I don't know why. But yeah, I like this answer because it also have the calculation, so you can check if it what you wanted in this situation. Okay, now let's try coding. Honestly, these small models aren't very good in coding, especially if the programming language isn't Python. So I tried this question. Write a function in Rust called cipher that it returns a string where every character is the next one and make the test pass. So I provided the test and I wanted this test to pass. I know that many people prefer to make a snake, but I think it's more useful to provide the test to the artificial intelligence and then get the code, or do changes in a code base, which is more interesting than zero-shot coding, which can also be done with cut and paste. And here we have the first solution from Gemma2, and this code is wrong. So this model it's fast and useful, but not for coding, at least for my test. Then we have this one, Lama 3.1, and here we have a complex answer which is almost correct. So let's try this one. So I copy the code, and then in Rust Playground, let's try this answer. And okay, let's try run. Okay, it didn't provide the main function, but for what I see, the answer is close to the solution, but we don't have the main. So let's try another model, and this is Nemo, Mistral Nemo. Okay, this one, also this one is almost correct. We have the test, but we don't have the main as requested in the prompt. Let's try this and paste, and this is the test. Okay, we have one test passed. Okay, if you try to make it fail, let's try again, we see that now it is failing. So this solution from Mistral Nemo is correct. Probably the code it's a little bit weird, but it works. so don't trust just because it passed. But the important part is this one. We have, I don't know why, exceptions for A and also A in lowercase. So these are a little bit redundant, but yeah, we have the test that passes. Good Mistral Nemo, not exceptional. Let's try another one. This is qwen, okay? And with the qwen, the code seems to work, but if we test this code, the code do not work, and it use methods that do not exist. So not good in Rust. I have also another model which is optimized for coding, and it's DeepSeek Coder V2 16B Lite, and let's try this. And this it's almost right, and as you can see here, the letters are incremented but not the numbers. So even if this is a coding optimized model, in this situation it do not perform better than Mistral Nemo. So in this challenge I would say that Mistral Nemo is the winner. This one. So let's try another use case. Another use case is tools. Tools is, I think, a very interesting features of LLMs. And so in this situation, I wrote this prompt: write the updated PM10 value, so the value of air pollution, and this value comes from a sensor that I have at home, and this is the reply of the sensor. So it is JSON with the PM10 and then a value inside the JSON. And here we have Gemma2, which says that the updated value is 8. And to make it work, you also need to enable and provide a tool. So you have to do this question with the tools enabled. So Gemma2 works. Lama 3.1 also works, but it doesn't know if it is updated, but it is updated. If you do the same question without the tools enabled, it provides general answer about the air pollution, but not a value, because by default the local artificial intelligence do not connect on internet. Also Mistral Nemo reply with the value, and also qwen2.5 reply with the correct value that in the meanwhile it changed, so it's fine. Okay, so this is a very important feature, and another one is embedding. So if you have books or text data, you can provide some textual context, and it will build the embedding, so a technique to enlarge the knowledge of the artificial intelligence. And in my situation, I provided a book in Italian about decentralized finance, and the book was in Italian, but the question is in English. And as you can see, I asked how is composed a lazy crypto portfolio. Obviously, this is a very general question, but if you provide a context inside the embeddings, you can get the answer in Italian or in English, and it provides the correct percentages provided in the book. And this was qwen2.5, and also Mistral Nemo answered in the same way as in the embeddings, and also llama3.1 we have not a general answer, but the answer provided in the book. And here we have a shorter answer, but also Gemma2 it's providing a correct answer. And then probably the most interesting feature for me, it's big context support. And with big context, I mean that you can provide a big prompt with the context and some questions, and then you get the reply. There are many hallucinations, so you have to check in your use case if it is implemented in the correct way. And in this test of big context, that in other situation it is called also the needle in the haystack benchmark. You can see that many LLMs claim to support very big context, so very big prompts, but they deteriorate very fast. So if you provide a lot of data, they do not follow much the context, the prompt. They often they prefer to do a summary or hallucination, whatever. And here I have my context, which is 3 questions about the following text. And as you can see, this is 2000 2K context. So it isn't very big, but it's useful for this use case. So you can use this technique to provide a post or some comments, and then you can ask questions about the text that you provided. And here we have the first reply. So let's try with Gemma. So with Gemma2 we have the correct reply. So the first question is correct. The second question also is correct, Guangzhou. And the third question, the reply is it doesn't mention any typical Chinese food, and it's correct. But other models behave in a different way. This is Llama 3.1, and as you can see, we obtain something like a summary of the provided text, but we don't have the answers. So Llama 3.1 is wrong in this test. Mistral Nemo, we have a correct answer. So the person, the city, and the unknown answer. So it's correct. And I noticed that some models they reply sometimes with a general answer, but if you ask specific just in the provided text, you should have a behavior like this. And okay, the last one is qwen, and also qwen2.5 do something like a summary, but it doesn't follow the prompt, just do a summary or a similar thing. So in the big context benchmark, Gemma2 and Mistral Nemo are the winners, and the others are the losers. And yeah, this I think it's the most important test for me. But it's also interesting to see how you can improve the context in the prompt. So I did this test, which I called instruction following. And this test, it's quite simple, and it's this one. I write a prompt like this. Translate the following sentence in English. Pesa di più 3 kg di piume o 2 kg di piombo, ragiona passo passo. And as you can see, here we don't have the answer. They try to solve the meaning of the sentence. So not the translation, but the model tries to solve the question, but it's wrong. But you can try in a different way. You can provide the sentence inside something like XML. So you start with the context and close the context. And here you put the sentence. And then you ask to translate the sentence inside the context. And this way we have a less ambiguous prompt. And here we have the answer, so without trying to solve. So if you do this technique, probably it's the best way to ask answer to the models. So you can provide the context inside some HTML like tags, and then you ask at the end of the prompt to translate the context. In this way, I think it works the best. Let's try also with the Lama. And with Lama, we have it's the same issue. So it tries to solve the question. But with this context technique, you have also here a correct answer. Let's try with Mistral Nemo. And also here it tries to understand and solve the question. And here also with qwen we need we have a different behavior. So we have the translation of the sentence, and then it tries to solve the question. So we have both, but also here with the context technique it works better. So if you have ambiguous prompt, the best way to deal with this situation is to use this technique, in my opinion. So we see the 4 models, and leave me in the comment which is your preferred small LLM model. Another things to consider is the token speed, which is 11.885 tokens per second in response for qwen. So it's quite fast, but not always correct, qwen2. Then we have Mistral Nemo, which is one of the best models, small models for me, but is almost 5 tokens per second, so it's heavier to run. And also let's check the speed of Lama. Lama is 10 tokens per second. And then we have Gemma. So gemma2, it is 7.91 tokens per second. So if I don't have a winner, as you can see, it depends on the context, but probably with my tests, the best two are gemma2, which it support big contexts, and also Mistral Nemo, which is sometimes smarter in some situations. But for mathematical reasoning problem, also qwen2, I think it's very interesting to consider for this kind of scenario. That's it. I hope you found this video useful, and leave me a thumbs up if it was so, and see you in another video. Bye. Consapevole, tecnologia open source,